Hello everyone. Now we will study the product of vectors. We already are familiar with the addition of vectors, subtraction of vectors. Now we will study the product of vectors. Now, product of vector means if a vector quantity is multiplied with a vector quantity, what would be the result? So we will have two types of results. There is a possibility of two types of results, and those two results decides that how many types of product of vectors are there, right? So we have two types of products of vector. First is the dot product. This is also called as scalar product. And second type is cross product or vector products. So this is second type is cross product, and this is also called as vector. Now let me explain what are these two, right? So as the word itself indicates, if the product of two vector quantities is a scalar quantity, then such a product is called as scalar product, right? And this scalar product is represented by a dot between the two vectors. So the other name for scalar product is dot product. Similarly, if the result of the product of two vector quantities is a vector quantity, then such a product is called vector product. And this is represented by a cross between the vectors. So this is also called as cross product, right? So if we have the product of two vectors is a scalar quantity, then we have scalar product, right? And here the product of two vectors is a vector quantity, right? This is called vector product. Now how to represent these? If I have a vector A and vector B, right? And the angle between the two is theta, then the scalar product is represented by first vector dot of other vector. That's why this is also called as dot product. And the formula is A magnitude multiplied by B magnitude into cos of the angle between the two vectors. Similarly, if here I have this one vector A vector, right, and the second vector B vector, the angle between the two is theta, right? Then if I am writing A vector cross B vector, that means their result will be a vector quantity. That's why this is also called as vector product or cross product. So this is not multiplication, this is actually cross, right? This is A magnitude, B magnitude into sine of angle between these two vectors. This part forms the magnitude part of this formula. So this part forms the magnitude part. Let me specify this here because this is very important. So this part forms the magnitude part here. Now we know that its result is a vector quantity. So that means there must be some direction also. And that direction is given by n cap, where n cap is a unit vector normal to the plane containing A and B. Suppose I have this A and B vector in this plane, which is this board. So right hand fingers rule, so the right hand thumb rule. So fingers are along the sequence of the vectors, then thumb gives the direction of the normal vector, which is normally outward to the plane. So if I am showing these fingers A to B, then A cross B direction will be along the thumb, right? In other words, I can say that n cap is a unit vector normal to the plane of A vector and B vector, right? And the direction of n cap is given by right hand screw rule, right? So the direction of n cap is given by right hand screw or right hand thumb rule, right? So right hand screw rule, I can say that right hand screw rotates like this, then this is the direction of the point of the screw. So this n cap is here normal to the plane containing A and B, right? So if I write B cross A, if I change the sequence, the direction of n cap will be reversed. That I'll tell you when I'll discuss this cross product in detail. But for now, we are concerned with what are these scalar and vector products. So these are the formulas and this is the basic definition. Now I'll take these vector products and scalar products one by one, right? So I'm first taking the dot product, okay, and I'll drop the rest of the part. Now here, as I told you, when we have two vectors and their product is a scalar quantity, then such a product is called scalar product, also called as dot product because it is represented as a dot between the two vectors. So here we will proceed to the properties of dot product, or we can say scalar product, right? So what will be the first property? We know here only magnitude is involved, no direction is there. So I can change the sequence. I can write BA cos theta, then it will be B dot A, right? So I can say that dot product is commutative. What does commutative means? That A dot B vector is equal to B dot A vector. We know that no direction is involved. So we can say the magnitude of A into B into cos theta or magnitude of B into magnitude of A into cos theta, one and the same thing. So that's why this is commutative. Second is distributive. Distributive means if I want to write this A dot B vector plus C vector. This can be written as A dot B vector. So this is distributed over the two. And A dot C vector. So this is distributive, right? Then we have the third thing. If A vector is perpendicular to B vector, look at this. If A is perpendicular to B vector, what does that mean? That the A and B vector are like this and theta is 90 degrees. So here, what will be the formula now? If A is perpendicular to B, we know that A dot B vector is magnitude of A, magnitude of B, cos of angle between the two is 90 degree. So cos 90 is 0, right? So this is 0. So that means for two vectors the dot product is, for two perpendicular vectors the dot product is 0. So we can say that dot product is 0 for two perpendicular vectors. No problem at all. Right? Similarly, I can write the fourth property as well. So this is about the basic properties. I am rubbing the board to write the next properties. So let's write the fourth property of dot product. I am talking about dot product or scalar product, right? So the fourth property is if A vector is parallel to B vector. What does that mean? That means this direction, right? So if this is your A vector and this is your B vector, that means theta between the two is 0 degree. So how can you write the formula now? A dot B vector is equal to magnitude of A, magnitude of B, cos of 0 degree. Right? So we can say cos 0 is how much? 1. So I can write down A dot B is equal to AB if these vectors are parallel. Right? Next we move on to the unit vectors. Unit vectors are also called as base vectors. Unit vectors along x and y, x, y and z are also called as base vectors. That is I, j, k. So I am talking about these unit vectors. If I say that I dot I, what does that mean? Magnitude of I, cos of angle between I and I is 0 degree. And what is magnitude of I, magnitude of j, magnitude of k? This is 1. These are unit vectors. So I can directly write it. This is 1. This is 1. Cos 0 is 1. So this gives me 1. Similarly, j cap dot j cap can be written as 1, 1. Cos of angle between j and j is 0 degree. So this gives me 1. Similarly, k dot k cap will also be 1. But if I write I dot j, what will it be? Magnitude of I is 1. Magnitude of j is again 1. But cos of, how much will be the angle? Look at this diagram. We know that I is the unit vector along x direction. J is the unit vector along y direction. And k is the unit vector along z direction. So what is the angle between I and j? This is 90 degree. Angle between I and k, 90 degree again. And angle between j and k is also 90 degree. So here we can write I dot j means magnitude of I, that is 1. Magnitude of j cap, that is 1. Cos of angle between I and j is 90 degree. And cos 90 is 0. So I dot j is 0. Similarly, j dot k, k dot I I dot k, because this is commutative. So j dot I and k dot j. Commutative है ना, so I dot j or j dot I. These will be same. If this one is 0, so the reverse will also be 0. Right? So this is another property. Now, next property, all important point you can say is, we know that if we have to find the angle between the two vectors, we know that A dot B is equal to AB cos theta. Right? So if I want to find the angle between the two, I'll have to write this. A dot B vector upon magnitude of A into magnitude of B. Because if we are simply writing A, so that means it's magnitude of A. If we are simply writing B, this means this is the magnitude of B. Right? Now, let me tell you how to calculate A dot B vector if you are given two vectors. So, I'll rub the board now. Now, if you are given two vectors in this form, I can take the example to explain it more, but for now I will tell you this. So, this is the second property. If you are given this A vector, suppose this is given like this, AX I cap plus AY J cap plus AZ K cap, where AX, AY and AZ are the magnitudes along I, J and K axis. That means X, Y and Z axis respectively, right? So similarly, B vector can be written as magnitude along X direction multiplied by I cap, magnitude along Y direction K cap for the Z axis component. So this will be like this, right? If I have to find out A dot B vector. Now beta, when we simply multiply the things, what do? We multiply the first quantity with the whole equation, second with the whole equation, third with the whole equation. Right? But we know that I dot I is 1, J dot J is 1 and K dot K is 1. Rest are 0. So I'll just take one longer step to help you in understanding this. So I'll simply write, how will I take the product? I'll simply write down this AX I cap plus AY J cap plus AZ K cap. Right? So I'm taking the dot. This is BX I cap plus BY J cap plus BZ K cap. Right? So I'm just multiplying this and I'll see what will be the result. So I'm simply multiplying the whole quantity by this. So this is AX I cap dot. This is BX I cap plus BY J cap plus BZ K cap. Now this quantity plus AY J cap dot. This is BX I cap plus BY J cap plus BZ K cap. So boring to write all this, but still you need to understand the step. So AZ K cap now, it's turn now. So this dot, this is BX right. Now look at this. We know that if we take I dot I, it will be 1. If I take I dot J, this will be 0. If I take I dot K, this will be 0. So I'll get only this quantity, that is AX BX into I dot I. I dot I is 1. Plus, so rest I can write 0. Now look at this. Why I am writing with different colors so that you understand that I have not skipped anything. I am writing this part 1, I dot I1, rest of x dx, this part 0, this part 0. Similarly here, this is the first part, j dot I is 0, so this part will completely 0. J dot j is 1, so I can write their coefficient ay, by plus j dot k is 0, so ay into bz will also be 0. Right? If I look at the third part, again k dot I is 0, k dot j is 0, so k dot k is 1, so az into bz into 1 will give us this. So what will be the final result, beta? This will be ax bx plus ay by plus az bz. Let's take an example. Let's take an example to understand how to calculate this dot product. Now let's take a vector is suppose 2y plus 3j plus k. Right? And I have second vector as I minus j plus 2k suppose. That's an imaginary vector I have taken. So how can I find this? I know that the coefficients of I are multiplied together, right? Coefficient of j are multiplied together and coefficient of k are multiplied together. So directly I can write a dot b vector will be, coefficient of I here is 2. Coefficient of I here is 1 plus coefficient of j here is 3. Now coefficient of j here is minus 1. Very important. People tend to do this mistake. Right? So always consider the coefficient with sign. Plus coefficient of k here is 1. Coefficient of k here is 2. So what is the result of a dot b here, beta? This is 2 minus 3 plus 2. So what is the result here? A dot b is 1. Right? I hope you understood that directly we can calculate the dot product very easily. I can take another question using these properties here. So I think the properties are done here. So we can take some questions to understand these properties more. This was one question. So I'm rubbing the board and taking another question to explain. Now, let's take another question for this. Find the value of lambda so that the vectors a and b are perpendicular. So if a is given, find lambda if a is perpendicular to b vector. And what is a given here? A is given as 2i plus lambda j plus k. And b vector is how much? 4i minus 2j minus 2k. So they have given these are perpendicular. So for perpendicular vectors, dot product is 0. So if dot product is 0, that means a dot b must be 0 if these are perpendicular. So I can find the dot product. What is the coefficient of 2? Coefficient of I in first case 2 multiplied by coefficient of I in second case. I will just write this here, rewrite here again so that it is easy for you to comprehend, right? So if I have a vector is equal to 2i plus lambda j plus k vector, right? And b vector as 4i minus 2j minus 2k vector. Now I have to find a dot b. So this will be a dot b is equal to 2. I coefficient here is 4 plus coefficient of j here is lambda. Coefficient of j here is minus 2, right? Coefficient of k here is 1. Coefficient of k here is minus 2. And this a dot b comes out to be 8 minus 2 lambda plus minus 2. So this comes out to be 6 minus 2 lambda. And this a dot must be 0. So I can write 6 minus 2 lambda is equal to 0. So I can write 6 is equal to 2 lambda, right? So lambda is how much? 3. So this is also a method to calculate the value of unknown coefficient if two vectors are given perpendicular to each other. Now we have discussed all this vector product and their properties. Now we need to understand what is the geometrical interpretation of dot product, right? I'm rubbing the board. So for geometrical interpretation, we need to understand the meaning of projection, right? Projection means if you are given is arc, right? Suppose A and B is an arc and you want to find the projection on this line L. Then what do? We drop a perpendicular here. We drop a perpendicular here and this MN is the projection of AB arc on line L, right? So here I am explaining the geometrical interpretation of dot product in terms of its projection, right? So here geometrical interpretation of dot product, right? If I have two vectors, A vector and B vector, and I want to find the projection of B vector on A vector, right? So this is theta, right? So if I want to find this value, this will be how much? B cos theta. And B cos theta can be called as projection of B vector along A direction, because we know that this point is here, so its perpendicular will be here. Its perpendicular is here, and this part is how much? B cos theta. So what we can say that B cos theta is the projection of B vector along A vector. We can take the other way around, right? I can take the projection of this A vector along this B vector, but I'll have to extend this direction. So this will be the projection. This is the A vector. This is my B vector. And this is theta. So what will be this value? This value will be A cos theta. Right? So in this case, more accurately, I'll have to write it on the other side. This is not giving the exact length. So I will say that this part, this is A cos theta. So in this case, I can say that A cos theta is the projection of A vector along B vector. dot B, I can write A dot B vector can be written as either A into B cos theta, or it can be written as B into A cos theta. So I can write, what is A dot B? A dot B is the product of one vector and the projection of the second vector along the first vector. Right? Here also if we consider this as one vector, so I can write dot product is the product of one vector and the projection of the second vector along the first vector. This is the geometrical interpretation of dot product. So I can say that the geometrical interpretation of dot product states that dot product is the product of one vector and the projection of second vector along first vector. So here in this case I have taken first vector as A, right? And here I have taken first vector as B. So I hope the geometrical interpretation is clear. That's all for now. Thank you and have a nice day.